So today we'll see how to differentiate infinite series. Okay, so today we'll see how we'll differentiate infinite series. So we'll try to understand this topic with the help of example and direct solving question. Okay, so let me solve. Okay, so on. So the question is evaluate dy by dx. Okay, so in order to deal with the type of question, we'll try to see the repeated pattern. Okay, so clearly we can see that y is x to the power x to the power so on. So we can say that from here onwards, like from here onwards, okay, from here onwards, okay, we can denote it as y. Okay, from here onwards also we can take it as. So we'll try to take maximum possible repeating the terms. So if we see carefully, then this term, okay, from here onwards we can also write it as y. Okay, so in the next step I will write, okay, I can write it here. Okay, so now taking logarithmic both the side, it will be what, log y equal to log x. Okay, now so it will be y by x, which implies, okay, it will be x. So if I take this function to the right hand side, then it will be, okay, okay. So here we got our required answer, that is we have evaluated dy by dx. Now we'll see another question. Okay, up to infinity. Okay, so here also we have to evaluate, okay, this one. Now clearly we can see that y is root over of sin x plus root over of sin x plus so on. So if we see carefully, then we can see that our repeating pattern is starts from maximum repeating pattern. It starts from here onwards. Okay, and it is what, y, if we observe carefully. So we try to see our question uh, from the question. So it will be what, I write it here as, then it will be what, y equal to sin x plus y. Now squaring both the side, then it will be what, y square equal to sin x plus y. Now differentiating both the side, then it will be, okay. Now taking this term to the left hand side, okay, this term, then it will be what, cos x, which implies dy by dx is equal to cos x divided by 2i minus 1. Okay, so in order to deal with this type of question, we have to see the repeating pattern. Okay, so max possible repeating pattern. Okay, so someone can take from here onwards y, but it will not work. Okay, we have to take the max possible repeating pattern. Okay, so now we'll see some another question. Okay, up to infinity. So here we also have to evaluate dy by dx. So our objective is to find out what, max repeating terms. Okay, or we can say y in the right hand side. Okay, same meaning both the questions. Okay, okay, here our objective is to see, okay, y in the right hand side expression. So if we observe carefully, then the max repeating pattern is what, this one. Okay, and it is y. Okay, so I will take y equal to x plus y, and it will be right the, now squaring both the side, it will be, okay, now differentiating both the side, taking this term to the left hand side and taking common dy by dx, then it will be this one, which implies that dy by dx will be equal to 1 by 2I minus 1. Okay, it is our required answer or solution. Now we'll see some another question, okay, of a different type. So it will be y equal to sin x, here sin x, okay, sin x, and so on up to infinity. So here if we our question is to evaluate what, okay, dy by dx. Okay, so if we see carefully, okay, if we see carefully, then one can observe that the repeating pattern starts from here onwards. Okay, okay, so from here onwards we can see our repeating patterns. Okay, and it is what, y. So we'll start, we'll replace that repeating pattern by y. Okay, so it will be y equal to sin x or y. Now taking log both the side, then it will be log y log sin x. So it will be sin x into cos x, okay, into y. So okay, taking this term to the left hand side and taking common dy by dx, then it will be okay. So it will be 1 minus y into log sin x, okay, divided by this one, cot x. Okay, taking this function to the right hand side, then we will get our required dy by, okay, okay. So here we got our required dy by dx. Okay, like that we have seen different type of um, questions. Okay, so okay, that's all for today. So we saw different type of questions, as well some examples.